Assalamu alaikum everyone, I am Masharul Islam Moin. I will be presenting part A of my assignment on containerization concepts with a focus on Docker. At first I will talk about containerization. It is mainly used to package an application along with all its required dependencies into a single isolated unit known as a container. This approach ensures that applications run consistently across different environments, whether it is development, testing, or production. Containers are also lightweight, portable, and highly efficient, which makes them an essential tool in today's software development processes. Then the next slide is about containers versus virtual machines. Although containers and virtual machines seem similar, they operate in very different ways. Virtual machines include a complete operating system, making them heavier, slower to start, and more resource intensive. And containers share the host operating system's kernel, which makes them significantly lighter and faster. As a result, containers are ideal for microservices and cloud-native applications where efficiency and rapid deployment are important. Then the third slide is about importance of containerization. Containerization has become widely adopted in DevOps and cloud environments for several reasons. First, it eliminates the common problem of it works on my machine by ensuring consistent application behave everywhere. It also improves development speed, simplifies scaling, and enables smooth integration with CI/CD pipelines. Additionally, containers are highly portable, allowing applications to move easily across different systems and cloud platforms. Then the next slide is about history of containerization. The concept of containerization is not new. It began in 1979 with the introduction of root in Unix, which created isolated file system environments. During the early 2000s, technologies such as FreeBSD jails and Linux containers advanced these ideas, introducing secure and efficient OS-level virtualization. These earlier technologies eventually laid the groundwork for modern container platforms like Docker. Then the next slide is about evolution of Docker. Docker was introduced in 2013 by Solomon Hykes and quickly gained popularity because it made containerization simple and accessible. After becoming open source, Docker was widely adopted by developers and DevOps engineers. Its tools such as Docker Engine, Docker CLI, and Docker Hub streamlined the process of creating, sharing, and running containers. Today, Docker plays a central role in cloud-native development and integrates closely with orchestration systems like Kubernetes. Then the next slide is about Docker architecture components. Docker's architecture consists of several key components. The Docker engine is the core platform responsible for creating and running containers. The Docker daemon manages images, containers, volumes, and networks in the background. The Docker CLI provides a simple command line interface for interacting with the daemon, and Docker Hub serves as a centralized registry for storing and distributing container images. Together, these components form a complete and powerful container management system. Then the next slide is about Docker images and containers. A Docker image is a read-only template containing an application and its dependencies. When an image is executed, it becomes a container, which is an isolated environment where the application runs. Multiple containers can be created from a single image, making deployment repeatable, scalable, and efficient. Then the next slide is about essential Docker commands. Some of the most important Docker commands include docker run, which is used for starting a new container, docker pull for downloading images, docker ps for listing running containers, docker build for creating images from a docker file, docker access for executing commands inside containers, docker stop and docker rm for stopping and removing containers, and docker logs and docker inspect for viewing logs and detailed system information. These commands form the foundation for working the Docker effectively. Then Docker volumes. Docker volumes are used for persistent data storage. Since data inside a container is temporary, volumes ensure that important data such as databases is saved even when containers is stopped or are removed. Volumes also allow multiple containers to share data and provide better performance than traditional bind mounts. Then the next slide is about Docker networking. Docker supports various networking modes. The bridge network is the default and enables communication between containers. The host networks gives a container direct access to the host network. The non-network disables networking entirely, and the overlay network allows containers running on different hosts to communicate, typically in a cluster environment. This networking options allow Docker to support both simple and complex distributed applications. Then the last is summary. In summary, containerization has revolutionized modern software development by providing a fast, portable, and consistent environment for running applications. Docker simplifies the entire container lifecycle through its architecture, commands, volumes, and networking features. These concepts form the core of DevOps practices and cloud-native systems today. Thank you. Welcome to practical demonstration of Part B, Containerization Concepts using Docker. In this first section, I will install Docker Engine on Ubuntu 25.04. To begin, I update the package index and install the necessary dependencies. That's why I run the command curl -fssl http getdocker.com -get.docker.sh. Okay, then ls for check it, then sudo.get.docker. Okay, after installation I verify the Docker engine version, then the Docker is successfully installed on the system. I check system information using. Then in the second section I demonstrate how to configure Docker Hub. Docker Hub is an online registry that stores public and private container images. I begin by creating an account at hub.docker.com. Then from the terminal I log in using the command docker login. After entering my username and password, Docker authenticates the session. This allows me to pull or push images directly between my local environment and Docker Hub repositories. After the verification, the part 2 is done. Then in part 3, I will demonstrate how to pull images from Docker Hub. Pulling an image means downloading a pre-built container image from the registry to the local system. For example, I use the following commands: docker pull Nginx, docker pull MySQL, then docker pull Redis, then docker pull Mongo, then docker pull httpd. Each command fetches the latest version of the image from Docker Hub. To verify download images, I run docker images. This lists all images present locally. Then in the section 4, I create running containers from the downloaded images. A container is a running instance of an image. I use the following commands to start containers for Nginx and Apache HTTP server. I face some backing issues on my Ubuntu. That's why I am so sorry. Here the dflag runs the containers in detached mode, and --name assigns a name to each container, and -p maps host ports to container ports. To check if the containers are active, I execute docker ps. Okay, in the section 5, I demonstrate how Docker volumes are used to persist data. Volumes store data outside a container's writable layer, ensuring that information is not lost when a container stops or is removed. I begin by creating a volume using volume create my data. Then I attach this volume to a MySQL container using these commands. This command mounts the volume my data to the MySQL data directory. And finally, I check the volume details. The output displays the mount path on the host machine, confirming that persistent storage is configured correctly. Yeah, it's done. In the next part, I demonstrate Docker networking, which allows containers to communicate with each other. First, I list all existing networks using Docker network ls. Then I create a custom network using Docker network create mynet. Next, I connect two containers, a web container and a database container, to this network. To verify connectivity, I can execute docker run d name wave -network mynet Nginx. Docker run d name db -network mynet, then MySQL root password root MySQL then docker access it web bash okay, then ping db c4 ping command not found, no problem, apt update and apt install -y. I put ILS ping, okay, then I can ping successfully, so I can check this ping dbc4. Yeah, now it confirms that both containers are communicating over the same network. Okay, then exit. For check this, I can write again sudo docker network inspect mynet okay, it's done. And in the final section, I review container history and logs. For review the container history, the command docker history nginx shows the images layer history, including the size and creation time of each layer, and then the logs. It is done. Thank you so much for watching this video.